presentation. We will summarize our project and our working methods. So I suggest that we do the presentation first, followed by a question and answer session, and then we can show you our work.
Okay.
What do you think, sir?
That sounds fine.
Okay, nice.
And before we get started, real quick, I have a hard stop because I have another team that I need to be on with at in 1 hour. So at about 10 minutes until, I will stop. And if I have any questions, I'll ask them. Otherwise, I'll just leave after about an hour. Thanks.
Okay, no problem. Okay. So as you know, our team participated in the competition last year, and since it was our first experience, we made some mistakes. Therefore, this year we decided to use a simple design to correct those mistakes and develop certain points therein. Before discussing what has been implemented and introducing the various components, let's have a brief overview of our projects. For our supersonic rocket, which will travel at Mach 1 as it exceeds the speed of sound, we used a simple design with a conical nose cone here, and with a conical nose cone, the payload section, here the main parachute, the electronic compartments, drug parachute, and the propulsion system, as you can see here. So here there is 3 trapezoidal fins, the upper and the lower body tube. As for the length for the vehicle, it is about 110.24 inches, and the weight is about 31.92 pounds. Now, let's talk about flight characteristics. After using open rocket and following SRR recommended flight parameters, we obtained the following results. Now, the static margin is about 1.65, predicted apogee 10,345.87 feet, maximum velocity 1,143.53 feet per second, maximum acceleration 14.83 g, and the total drag coefficient is about 0.49. Now, to choose the appropriate engine, we conducted a comparative study of several engines, and Cesaroni 9994M 34W0P gave us the best results. And here are some characteristics of the engine. The average thrust is about 3,414 Newton, maximum thrust 3,898 Newton, and burn time 2.92 seconds. In this part, we will discuss each part of aerostructures subsystem. We'll start with the nose cone. Our study has confirmed the significant influence of the nose cone shape on mission objectives, and we discovered that a pointed head minimizes thermal and physical stresses by reducing the contact surface, especially when starving to achieve a high-speed supersonic regime, and also ease of manufacture influenced our choice of the conical shape, considering our available capabilities. Here is our conical nose cone. And to realize the nose cone, we used this polyamide mold, which was manufactured using CNC technology. We first cut the fiberglass fabric according to the conical shape's projection. Then a mold release agent was applied to the mold. Then a sheet of parchment paper is placed to separate the fiberglass fabric from this mold release agent. And then we gathered together the fiberglass and the epoxy resin. We applied 4 layers to achieve a final thickness of 2 millimeters. Now, this nose cone will be assembled with the upper body tube using a coupler made of PVC. And here we place our payload and 2 bulkheads. Now we're gonna talk about molding system for rocket fuselage and body tube.
Regarding the manufacturing method of the upper and lower body tubes, as well as our motor tube, a new molding system was developed this year, as you can see in the slide. In this system, we have two tubes. The first one has a diameter matching the inner diameter of our fuselage, which is about 6.299 inches. The second one matches that of the motor tube with a diameter of 3.858 inches. This system was developed to simplify the molding process, and similar to the method used for manufacturing the nose cone, a mold release agent is applied to the mold. Then a sheet of parchment paper is placed to separate the fiberglass fabric from the mold release agent. Next, a first layer of resin is applied, followed by the addition of the fiberglass fabric. This process was repeated several times, resulting in a thickness of 2 millimeters or about 0.0787 inches. Next slide, please. Here are the results of our work. Here are the body tubes, as you can see there. Here we will place the upper body tube between the nose cone and the electronic compartment. The electronic compartment will be housed within a coupler that connects the upper and lower body tube. So it plays simultaneously the role of an electronic compartment and a coupler. In designing the fins of our rocket to enhance the fin's resistance to flutter, we incorporated a 20 millimeter or about 0.787 inch fillet radius into their design. This addition helps with reducing the likelihood of reaching fin flutter velocity, which is about 1,665.86 feet per second. Our attachment strategy involved the use of slotted centering rings and fin retention, along with applying epoxy to the bottom of the fin tab. These design choices are backed up by a comprehensive comparative fin flutter analysis conducted using ANSYS Fluent. Here are the results of our work, as you can see there.
Regarding our progress in fin manufacturing, we have produced a fiberglass sheet and we'll create 3 fins from them. The method we propose involves printing the fin shapes, applying them to the sheet, and then cutting them using a cutting machine according to the shapes. Here you can see the fin attachments. In order to ensure secure attachment of the fins to the rocket, we've made a decision based on ease of manufacturing, which led us to choose the option of slotted centering rings and engine retention, as shown here is in this picture. They will be glued with the epoxy resin onto the motor tube, ensuring the optimal alignment. As you can see here, the method we opted last year, and we will adopt this year as well, is distributing the slots slots evenly spaced, achieving a 120 degrees spacing.
Now talking on our eBay and electronic systems, we are willing to compete with a full cost system that includes 2 main altimeters. The main one, which is Easy Mini board, and the redundant system that is RRC2 Plus altimeter. Plus the simple GPS tracker from Apogee that will help us locate and track our rocket later. We're providing proper power supply for each system that's gonna be installed within the eBay. Also, we're installing the power switches on the outer airframe to keep the system more accessible as possible.
Now, talking about recovery system, after reaching 10,000 feet, the drogue parachute will deploy and the rocket will descend at rate of 98.4 feet per second, same as the main parachute will deploy after reaching 150 feet, 500 feet, and the rocket will descend at rate of 29.5 feet per second. And to ensure a safe descent, we have calculated the dimensions, and here are the following results. Diameter or parachute diameter of the drogue, 35.43 inches. the main 118.11 inches, diameter of chimney in drug 6.69, in the main 22.91 inches. Now, for the number of ropes we're gonna use for the drug parachute is 6 ropes, and the main 20 ropes. And the length of these ropes in the drug is about 53.15 inches, and the main 177.16 inches. That's it for our presentation. Ready for your questions.
Okay. So it looks, looking at your previous diagram there, your electronics bay, which doubles as your coupler, is that? Yeah, if you can go back to the flight diagram.
Mm-hmm.
Yeah, that guy. So when it's under main, it looks, so is your is the electronics bay / coupler, is that a separate unit that's when the main and the drogue are both deployed, it's kind of floating there in between? Is that what I'm like in the number 6 there?
6 ropes.
In the diagram on the right hand side. Yeah, there you go. We're number 6 where it's under drogue and main, and is that the electronics bay floating there in the middle?
Yeah, because our electronic our avionic chamber is in the middle.
Okay, so when it's under drogue, what is retaining the electronics bay inside the forward section before the main has deployed? What prevents? Right. So when the drogue deploys, and then you've got all those forces on the coupler, which is still in the forward section, and the main chute hasn't deployed yet. If for some reason you have a very energetic deployment of the main, what's going to prevent that coupler section from being pulled out and getting your main deployed early? Is it is it retained with some sort of shear pin, or what keeps it in there before the main chute's deployed?
Anybody can answer this question?
Please, can you repeat your question? I haven't get you.
Okay, so when the drogue is deployed and the main is still, the main has not been deployed, and so you've got your electronic section coupler, which is still in the forward tube, the forward airframe, and so when that drogue chute deploys and you have some forces pulling on that coupler, what's keeping it from being pulled out of the forward airframe before you want the main chute to deploy?
We're going to use shear pins.
Okay, and so I guess I should ask, have you guys tested this flight configuration before?
Yeah.
Because my concern there is you're walking kind of a fine line as far as those shear pins being strong enough to keep that in there when your drogue deploys, versus being too strong that your charge won't push it out for the main. So I just want you guys to call that out as a potential concern there, just to make sure. I would see that as potential failure mode there when your drogue chute deploys. If there's too much force when that happens, if you're not as, if the rocket's traveling faster than you expect it to, that drogue chute deploys and it pulls harder than you're expecting, it could potentially pull your main chute out early. That's just the concern I'm trying to call out there. The other thing, kind of along the same line, is are you doing anything to protect the recovery line between the fin can and the electronics bay when the drogue deploys? Because you've got an open tube there, and so again, what can potentially happen when the drogue deploys is your booster section is still traveling forward. That parachute comes out and it stops everything, and it pulls on the open end of that tube, and you can potentially zipper down your airframe and cause other problem. Or worst case, cut your recovery line and your booster separate, or your fin can ends up separating. Do you guys have any plan on reinforcing or protecting the recovery line where it hits the edge of the bottom airframe?
We're going to use here a bulkhead. This bulkhead, we tested this bulkhead to resist these forces.
Well, okay, so the bulkhead is good, but what about where the line will lay across the open end of the tube, that edge of the open airframe?
No.
There. So another thing to call out there, a lot of the time people will either, see where that, you've got the tube and you got the recovery line in there, where it's going to hit the edge of that tube. You want to make sure you may need to add either an extra layer of of a webbing over that or something, because that's another potential failure point where it can catch on that edge and actually cut the line.
Okay.
So keep an eye on that. You guys do you guys have your motor? Has it already been acquired? The reason I ask on that is the Cesaroni motors right now are getting really hard to get, because they're not producing as many commercial motors. So if you don't already have it lined up, make sure you start working that immediately. And I would recommend having a backup choice in mind, because like I said, I hate for you guys to get there last minute or getting up to the deadlines and realize you can't get a hold of the motor.
Okay.
We have already ordered this motor from Animal Works.
Okay, and they've told you that they'll have it for you?
Yeah.
Okay, good. I just want you guys to keep an eye on that, because the Aerotech also just sent out a message about their motors being backed up, delayed. So just keep that in mind. Let's see. Another question. How about what type of switches are you guys using for enabling your electronics?
Is that?
Okay, are they like rotary key switches, or what mechanically, what are they? Okay, cool. Just another thing I always need to keep an eye on. Okay, good presentation, by the way. You guys did a really good job of covering all the parts of the rocket.
Thank you.
Let me see if I've got any other questions here. Are you using black powder deployment charges?
Yeah.
And okay, that's fine. Just make sure you do your ground testing, that kind of thing, to make sure your charge sizes are appropriate. Nose, you don't have anything in the nose cone, right? There's no electronics or payload or anything like that?
No, just the payload.
Okay, and it's secured. It doesn't get deployed.
Non-deployable.
Yeah, and are you flying a separate payload, or are you flying a payload? Do you guys have any information on that?
Can you repeat, please?
Are you flying a payload project of any kind?
Our payload is inert for the moment, and we don't know if we can make it
deploy or not.
Yeah.
Okay, that's fine. Recovery, your parachutes. And you got your electronics down. Are you guys doing any kind of telemetry? I don't think I remember seeing that or not. Any kind of tracking? Okay. Okay, that's fine. You guys got your fin flutter calculations. But do you for your rail buttons, do you guys have those already? Are you using a commercial off-the-shelf rail button, or are you making those yourself?
Commercial.
Okay.
According to Ishra launch line.
Perfect. Okay. I think we've covered everything, and you guys have been to the event already, so you're already aware of all the details related to that. One thing that's changed is Last year you had to provide your own tent. This year they're providing tents for you. You still have to have your own tables and chairs and that sort of thing, but you won't have to worry about having an overhead. That'll be provided. But everything looks good. That's all the questions I got.
Okay.
Thank you.
Thank you for your insight.
You guys have a good evening.
So,
Okay.
Hey,
See
team.
you.
Hey team, I have
Yeah?
I have a few questions if that's all right, since we got a little bit more time. I think I heard that you said that you plan to have the coupler for your nose cone. Is that going to be made of PVC? Is that what you said?
Yeah. This couple.
Okay. I think from what I'm seeing, I do not believe PVC couplers are allowed.
Okay. And what can you recommend for us?
It actually is called out that it is allowed. PVC, quantum tube, steel, stainless are allowed in couplers.
Are allowed inside. Okay, got it. I'm seeing that right here. Okay, that's my bad. And then
I was curious about that as well. I had to go look and see.
Yep. Did you guys do any compression testing on the tubes? So 2 millimeters is really close to what would be about an 16th of an inch wall, which is a standard wall here in the US. Have you done any compression testing on your tubes?
No, because we're gonna use the same system. We didn't make or testing these tubes. So it's the same result like the last year.
Do you have the rocket? Can we see it?
Currently it's disassembled, but I can show you some parts of the rocket.
Yeah. What is the state? Is it mostly assembled, or is it still got a lot of work to do?
So we are preparing them for the painting workshop. Almost everything is done. So we have our three tube. Just you have seen before in the presentation. So the nose cone is here, and the motor tube is here. For the moment, we are our centering ring and bulkhead are being machined in with the plywood of 20 millimeter plywood, and we didn't get them for this meeting. Perhaps it will be tomorrow. We will receive them. For the parachute, it's not already assembled, but everything is done. I think that's all.
Can I also ask, do you guys have your electronics bay? Is that assembled? Is that something you can show us yet?
For our electronic base, so we have ordered everything in the with animal motors, animal works, just to avoid to have to get them in Algeria and to take it another time. So everything we will be in the state 1 week before the competition, just to assemble this part.
Oh, that's pretty late in the game there.
Yeah, that's pretty late. Okay, that's good to know. So speaking of that, do you guys have visas and airline tickets and a place to stay? Have you got that already arranged?
Yeah. For the moment, not yet. So we will prepare it. We should prepare everything before the 1st of June. So if you want, we can make you send you an update after this after 1 week or about this point.
Yeah, keep me in the loop. You guys have visas, because visas are probably going to be very difficult to get at this late in the game.
You are talking about what?
Visas for your passport for entrance into the US.
Yeah. For visa, it's okay. For almost of them of us, it's okay, and for 2 new members, so it will be done this week or or for the next week at least.
Okay.
Okay.
As long as you're thinking about that. All right. And then covered most of my points. How long are your shock cords and what are they made of?
Our shock cords is about 3 times the length of our rocket, so it will be about 9 meter.
Okay, good. Both pieces for the main and for the drogue?
Yeah.
And what's the material?
It will be Kevlar.
How thick? 1 centimeter to 1.5 centimeter?
I don't know. I will check. We have ordered this point with the animal wash also. So I will just check. Yeah.
Okay. If you're buying it from him, most likely it's good.
Yeah.
Very good. And then I know we talked about your shear pins, but how many shear pins and how big?
We will use the. I don't have also the reference. I will check. We will use 6 shear pins per compartment. Shear pin.
Are they like nylon M3?
Nylon. Not. I will show you. Just a second. Works. Shear pin. Not works. Apogee rocket.
So are they number 4? Number
4.
2?
The number 4. Yeah, exactly.
Okay, those are big. So you use 6 number 4s.
Yeah, just like last year, we used the 6 shear pins, and we had 4 grams of black powder to make the separation.
Okay, but last year you came in ballistic, right?
What?
Last year you came in. You did not get a main.
Yeah.
Okay.
Do you have any recommendation for this point?
So on the flyer record, so I would say 6 is probably too many, considering how big your rocket is. I would say 3 is about right. So if you have 3 number 4 shear pins, and then I would say your black powder charges between 4 and 6 grams. I think that is about right, because that's typically what I use for a rocket like yours.
Okay, so for ejection test, we will do it on site, so we can test it before.
Yep, I'll be there with you for that. So we'll see how the test goes, and then we'll adjust as needed.
Great.
And I'll help you with that.
Great.
Brian, do you have any concerns? I was referring to how they have the floating eBay coupler that's basically attached shear pins on both sides, and the potential for deployment of main at apogee.
I would rather get a main at apogee than no main at all.
Absolutely, yeah.
That's my opinion. I don't really have that much of a concern, because it really doesn't matter where you put it. So you could put those shear pins up near the nose, and it's functionally the same thing. So they could be up where the nose cones are, or they could be at the eBay, as long as it's going to be energetic enough to where it's going to pull out that parachute. What we don't want is, and the attachment point is going to be important there. I want the parachute attached closer to, or actually on, the hard points of the electronics bay instead of the nose, because we need it to pull that parachute out of the body tube. I've seen it a couple times where the parachute stays inside even though we get separation, and we get no main, and then it just crashes down. So I'll help you with that as when we get out there as well, to make sure we get that right.
Great. I have a question. Do you have any recommendation for the electronic bay? So you said that it could be problematic for us during the main parachute ejection. So what do you recommend for us?
I think your plan is fine, in my opinion, as the flyer of record. I think your plan is fine. It's a little different than we typically see, but I've seen some wild things in some of the designs. So yours isn't that far off.
Great.
What do you think, Greg?
Well, just other than what there's a concern there for early deployment, but like you said, that's not the end of the world, and it's not like this is a level 3 cert where that's going to cause them to fail or anything like that. So, I mean, if it was more of a concern, you could change design where instead of the eBay being deployed to remove the main, have the nose cone deploy to get the main out. So you're that sort of situation. So you don't have those potential loads on those shear pins that are supposed to physically hold things together. But I mean, that's like Brian was saying, that's an okay failure mode. You're not better than coming in ballistic.
So the idea is was just to have two separate parachute compartment. So in our mind, it will not be affected by the lower one will not be affected by the main parachute. So that's why we have opted for this solution. And if you have any other recommendation that we can do, and it's more secure, I'm talking about Mr. Ryan and Mr. Greg. So if you have any other secured solution, it will be okay for us just to adjust if there is no big adjustment to do.
Yeah, like I said, I think it's fine. I don't see a bigger problem.
Great. Thank you.
You're in good hands with Brian.
Thanks. What are you planning to do for vent holes? Have you thought about pressurization equalization holes for the avionics bay and for the main tubes?
Exactly. We are planning to do to have at least one hole in the electronic bay. Mr. Islam, huh?
Do multiple holes in the electronics bay. So don't do one big hole, because what happens is
3 small like this. It will be better.
Yes.
Thank you. We will calculate this hole diameter and how many.
Yep. Take the same area as one big hole, and the same area have 3 different holes, or more, 6.
Yeah,
that would be even better. That way, what happens is it gets very windy out there, and you can get pressure fluctuation inside the avionics bay. The avionics that you have are very good. They're most likely not going to be fooled by the pressure fluctuations, but it's always good practice. And then also in your where your drogue and where your main is, you will need at least one hole. I would say about 3 to 4 millimeters to allow the air to equalize in pressure as you go up. Because what we don't want is the pressure vessel to stay pressurized, and as the pressure goes down outside as you go up, they cause an early deployment.
Can you repeat? What do you recommend?
So where in the main body tube,
where
your drogue and where your main parachute is, there should be a small hole about 3 millimeters, maybe 4 millimeters, to allow the air inside to escape and equalize with the outside.
Okay. I get you.
Otherwise, as you rise in altitude, the pressure outside is lower and the pressure inside can be much higher and causes the shear pins to break early.
Okay. And this will not cause any problem for us during ejection, parachute ejection, pressurization? Great.
It's too much. It's too fast. It won't let it out the little hole. It just
perfect.
You'll go.
Perfect.
Okay. If you do those things, and then the other most important thing I would say is actually how are you retaining the motor? Is the shock cord going directly to the motor, or do you have a commercial retainer?
Yeah. The shortcut is going directly to the motor. So if you have seen the Pro 98 from Cesaroni, there is how to say a screw. We can put a screw on inside and with a swivel, so it will be retained. That's all.
Okay. And then
Mhm.
how are you retaining the motor so it doesn't like fall out the back?
So we made an aluminium motor retention in the base of in the base of the rocket. I have it. I will I will come back with the
So is it like a little clip or is it something that
Screws with a screw.
Okay.
Mhm.
Very good. Oh yeah, I see it now. Okay, good. That's a good plan. I like that. Yeah, it's best to have the shock cord directly attached to the motor. That way there's no chance of it coming loose.
Yeah.
Very good.
I just remembered, I forgot to remind you guys, this presentation and review was supposed to be recorded.
Oh yeah.
Yeah, and I forgot to tell you guys to record it. So
I think my friend was recorded.
excellent. Okay, I'm glad because I usually that's the first thing I start with, and I completely forgot this morning. So good.
Excuse me.
And make sure that you submit that today because the deadline is tomorrow.
Yeah.
I forget our motor retention in our workshop, so excuse me, it will be not available for now.
It's okay.
I will send you a picture of this.
It's okay. As long as you're thinking about it and you have a plan,
Yeah.
we're good.
Yeah.
Thank you. So we know that we are a little bit late to be ready for the competition, but we are working hard every day. And we will be. I think we will be ready before the 1st of June. For my point of view, everything is done. So we are working just on the finishing. Yeah.
Okay. I'll say this. Since you have a lot to do, and you're trying to come early and everything like that, if you hit problems, please reach out to me so that we're communicating and I can help you and I can give advice, and then we're communicating with the competition so that there are no surprises, so that we know, if you guys have run into trouble or we need to buy something or your flights get delayed or you don't get a visa, we know what to expect and we can communicate that. So just reach out to me. You guys have my contact info, and other teams are just like this as well. I tell every team that. So
Great.
Okay, no problem.
Thank you.
All right. Thanks, guys.
Thank you.
all right.
Thank
Do you guys
you.
have any other
that's
questions? Any questions for me?
No questions for the moment.
Okay.
Oh,
Go ahead. That sounds good. Yep. Anything else?
For me, that's okay. Mohammed, do you have any question?
No, I don't have any. Thank you for your advice.
Fine.
We will take everything you said into consideration.
Sounds good. Okay. If you have any others, just reach out to me online.
Thank you.
okay. Thank you.
All right. Take care, team.
Thank you.
Thank you. Thank you, Mr. Greg. Thank you, Brian.
Have a nice day.
بون شبيبة الله يعطيكم الصحة.
Oops.
يهضر اللونجلي تاعي والتهرير تاعي. بيزارمون ما على باليش وقيلا نسيتها في البيرو لا ريبونسيون موتور. المهم جو بونس كو سا سي بيان باسي. دركا ما قالولناش كاين يا با دو موديفيكاسيون اللي خصنا نديروهم ولا على حسب واش قالوا.